Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic motion under gravity. Let's go to the numerical. A stone is thrown up with a velocity of 20 meters per second. While coming down, it strikes a glass pan held at half height through which it has risen and loses half of its velocity in breaking the glass. Find the velocity with which it will strike the ground. Okay. First of all, a stone. This is the ground here in this diagram. A stone at the point A from the ground thrown up with a velocity. That means with a value of initial velocity 20 meters per second. From the point A, it is going to thrown upwards. Okay. So we know that gradually the velocity decreases. This is because it is thrown against the gravity. That means it is thrown up. So it is against the gravity. So gradually the decreases in velocity and a point that is called as a dead point where the velocity becomes zero. Okay. So this is the upward motion of the stone, AB. Then while coming down, if it is the glass pan is not there or the stone is not going to hit and break the glass while coming down, then from a dead point, normally it will come and hit the ground. But here it is mentioned as when it falls down along its path exactly half height through which it has risen. It means that from the point A to the dead point B, it has risen a height S with respect to the height, half of the height. Okay. We are going to keep a glass window. Okay. While coming down, the stone going to hit and break the glass pan. Okay. Which is kept at exactly half the height in which previously the stone has traveled. Okay. Due to the breaking of the glass window, it loses its velocity. That means it loses half of its velocity while breaking the glass window. It means that at point C, it is going to hit the glass window at some of velocity, some of the value of velocity. After breaking the glass, the velocity of the stone, which is leaving from the glass after the breaking of the glass pan, it has only half the velocity of the value in which it hits the glass pan. Okay. So we can say 2 points here, C and C dash. That means C is the point at what velocity it is going to hit the glass window. Okay. After that, what will happen? It loses its half of its velocity. After the loss, it is going to leave with a half velocity with a value in which it hits the glass pan. That point here we are going to take a C dash. Okay. So here C or C dash is the same point. Okay. So here first I'm going to write the given data. Okay. First I'm going to write the given data. Here we are going to calculate the velocity with which it will strike the ground. Okay, that means this velocity we are going to find. Here, first of all, we are going to consider this entire motion into three segments. First one is the segment AB, the upward motion. Here, the stone is thrown upwards from the ground, say the point A, with an initial velocity 20 meters per second. So here, the initial velocity at point A, U1, that equal to 20 meters per second. The point B, that is the dead state in which the velocity becomes 0, then the free fall motion is going to happen. So the point B, this is the first segment. So V1, okay, here it is 0. Okay, in the upward motion A to B, U1, 20 meters per second, that is the initial velocity. The dead state at the point B, final velocity becomes 0. Then there is a free fall is going to happen. So at point B, now we can take the second segment BC. Here, it is going to fall. That means this AB, while coming down, it is going to hit the glass pan. So at point B, we can say the initial velocity. Now, the previous final velocity becomes initial velocity now. So U2, that equal to 0. Here, we have to calculate at somewhat velocity at point C, it is going to hit the glass pan. After that, C dash, it is going to leave the glass pan with a value of half of its velocity. Okay. So this one, we can take the third segment, U3. Okay. This U3 equal to V2 divided by 2. Okay. At point C dash, it is the U3. Okay. That value is value of velocity while it hits the glass window divided by 2. That means half of the value of the velocity before or at what time it is going to hit the glass pan. Okay. Then this final one, when it is going to hit the ground, that is a final velocity V3. Okay. So these are all the things we are going to consider. So first one, the given data. It's a simple data that is in the first segment. We can take the initial velocity U1, that is 20 meters per second. And then we know that U3, that is a half of the value of the velocity while it breaks the glass window. U3 is the velocity of the stone after breaking the glass and leaving from the glass pan at this point C dash. Okay, at the point C dash. Okay. So here we are going to find the final velocity with which it will strike the ground, that is V3. So this I'm going to take us into three segments. The entire motion I'm going to consider into three segments. the first segment AB, okay, it is an upward motion. Okay, it is an upward motion. Here, for our reference point of view, I'm going to write the kinematic equations for motion under gravity. Here, both the cases, we are going to consider the upward motion and also the downward motion. So for upward motion, V equal U minus GT. Yes, sometimes this can be mentioned as H also. That equal UT minus of GT square. V square equal to U square minus 2GS. Okay, this is for upward motion. Then for the downward motion, that is also I'm going to mention here. For the downward motion, the only changes, instead of the minus G, we got to replace with the plus G. Okay, so in the downward motion, V equal U plus GT, S equal UT plus of GT square. V square equal U square plus 2GS. So these equations, the related, which are all related for the given data, and the factors, what are all the things we have to calculate, we will use the equations from this. Okay, so it is an upward motion. Here, we know the value of initial velocity and the final velocity, V1 at the dead state, that equal to 0. That is also the known value. And then in the upward motion, the acceleration due to gravity, that will be minus G. So that is also known value. Here, we are going to find S. Then only we can calculate then what will be the half height where the glass pan is going to keep, okay, in the path of the stone while coming down. Okay, so the half distance we need, for that the total distance or height traveled by the stone in the upward motion, that we have to calculate. Okay, so this we are going to calculate as in the upward motion AB. Here we need S, and we have the value of final velocity, initial velocity, and G. So it's a it's using the third equation will be the convenient. So V square equal U square minus 2GS. I'm going to modify the equation. Here we are going to find only S. So we can write 2GS, that equal to U square minus V square. Then S equal U square minus V square divided by 2G. This is the general equation. Here, for to mention the first segment, AB, the upward motion is the first segment. All the values are suffixed with a 1. Okay, so S1 or simply S, that equal to U1 square minus V1 square divided by 2G. Okay, so S equal initial velocity 20 square, final velocity at the dead state it becomes 0 square divided by 2 into the G value 9.81. So if you simplify, you will get S equal 20.4 meters. Okay, that means this value, that equal to 20.4. then what will be the half of the value? S by 2, where the glass pan is going to kept. So that will be half of the previous value. It means that this will be 10.2. If this is 10.2, we know that this also 10.2. Okay, so this also the half distance, this also the half distance. So both will become 10.2. Okay, then we are going to consider the second one. That means second segment, motion BC. Here we know that this is a downward or free fall motion. Okay. So in this downward motion, we are going to consider the U2 value. That means here at point B, from the point B, it is going to fall down, and at point C, it is going to hit the glass pan. So we have to calculate at what velocity it will hit the glass pan. Okay. So at point B, we know that from the dead state or dead point, it is a free fall. So the U2, that will be 0. V2, we are going to find. Yes, we know that. Okay. So we can calculate the V2 value by using the same equation, but it is downward. So V square equal to U square plus 2GS. Here we are going to find only V. So V square equal U square plus 2GS. So as per the notation, V2 square equal U2 square plus 2GS2. The S2 is also 10.2. So V2 square, that equal to U2, that value is 0 because it is a free fall, plus 2 multiplied with 9.81 multiplied with S2. That is the half distance, okay, of the previous value. So that will be 10.2. Okay, that will be 10.2. So V2 square, we will get 199.9, approximately 200. So when you take the square root, we will get the value of V2, that equal to 14.14 meters per second. This is the velocity of the stone in which it hits the glass window. Okay, that means this is the velocity at C. Okay, this is the velocity at C. And here you can see it loses half of its velocity while breaking the glass. So in the third segment, okay, I'm going to mention the third segment, that is C dash D. That is the third segment, C dash D. We know that this is also the downward motion. Okay, this is also the downward motion. So in this downward motion, we know that due to the breaking of the glass window, the velocity of the stone becomes half of the previous value. So the U3, the velocity at point C dash, okay, U3, velocity at point C dash, that equal to V2 divided by 2. Here V2 we calculated 14.14. So 14.14 divided by 2, we will get 7.07. So U3 equal to 7.07. And we have the value of S3, 10.2. That means this we can take S1 this 10.2, that is S2, this 10.2, that is S3. That means the three segments. So S3, we know that 10.2, and then we are going to find V3. That means velocity at point D, where it is going to hit the ground. Okay. So here, the same equation we can use. V2 square equal to U square plus 2GS. And so here, V3 square, that equal to U3 square plus 2GS3. To mention, this is the third segment. Here, U3 has the value. Okay, previously it is a free fall, that's why it is 0. Here U3 at point C dash, we have some value, that is 7.07 meters per second. Okay, so V3 square, that equal to 7.07 square plus 2 multiplied with 9.81 multiplied with S3 value, that is 10.2. Okay. When you simplify, we will get the value of V3 square, that equal to 249.9. So take the square root of the value. So V3 equal to square root of 249.9. That means V3 we will get 15.8 meters per second. So V3 equal to 15.8 meters per second. This is the final velocity in which the stone going to hit the ground. Okay. We know that if it is a normal motion, okay, from point A to B, if it is thrown with a velocity 20 meters per second at point A, it reaches the dead state 0, and it is going to travel a height 20.4 in this motion. If the glass window or pan is not there along in this downward path, if it is a normal free fall motion, that means B to A, it is going to travel same distance. And we know that what is the time taken by the stone to reach A to B, the same time taken for B to A also. So it will hit the ground with the same velocity in which it thrown upwards. That means if it at point A, if it is thrown with an initial velocity 20 meters per second, it reaches the dead state 0, which is 20.4 meter above the ground with some time taken. From the dead state, it free fall. Again, it is going to hit the ground, means the final velocity will be 20 meters per second. But here, in its midway, exactly half of the distance, we are going to keep a glass window. The stone along its pathway going to hit the glass pan. So the velocity of the glass pan, velocity of the stone after striking the glass pan becomes half of the value while it is having, when it is having while break the glass pan. Okay. So here we calculated at what velocity it is going to hit the ground. That is 15.8 meters per second. Okay. If the glass pan is not there, it will hit the ground with the value of 20 meters per second, which is the same as what velocity it is going to thrown upwards. Okay. So due to the breaking of the glass pan, the velocity is decreased from 20 meters per second to 15.8 meters per second. Okay. So here we considered into three segments: AB, upward motion; BC, downward motion up to break the glass; C dash D, it means that after breaking to reach the ground. Okay. So we considered into three segments, upward and downward separately. We calculated the values which are all required to calculate the final velocity or the velocity with which it strikes the ground. Okay. So I hope you all understand this video. That means this numerical, what we discussed in this video. Okay. So subscribe my YouTube channel, Vishwaguru, a problem solver, for more videos. Because in further upcoming videos, we are going to discuss many numerical videos on this topic: motion under gravity, motion in straight line, D'Alembert's principle, okay, and the connected bodies, Newton's law of motion. So many things we are going to discuss. Okay. So thanks for watching this video. And don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Thank you, guys.